Good morning, everyone. This is the session 2 from the chapter of alternating current, and the topic is AC voltage across a resistor. So, here I have made one diagram in which a resistor having a resistance R is connected to a AC source. So, here I have considered an AC source which is producing sinusoidal potential difference across its terminal. So in this case, the potential difference is given by V is equal to Vm sin omega t, where Vm is the amplitude of the oscillating potential difference. So Vm is the amplitude of the oscillating potential difference, and omega is the angular frequency, which is given by 2 pi upon t, where t is the time period. So now here I will be applying the Kirchhoff's loop rule. I will be applying the Kirchhoff's loop rule in this electrical circuit, which is a pure resistive circuit. Now, as per the Kirchhoff's loop rule, the algebraic sum of the potential difference across all the EMF sources and the resistor in an electrical circuit is equal to 0. So, in this case, the potential difference V, that is Vm sin omega t, this will be equal to IR. Using the Kirchhoff's loop rule, I will be getting Vm sin omega t will be equal to IR, or we can simply say that I will be equal to Vm upon R sin omega t. Here, I is equal to, here Im is equal to Vm upon R, and this is called the current amplitude. Here Vm is the amplitude of the oscillating potential difference. Therefore, this Vm upon R is written as Im, where Im is the amplitude of the current, or you can say it is the current amplitude. So this equation can be written as, it implies that I is equal to Im sin omega t. So V is equal to Vm sin omega t, I is equal to Im sin omega t, and omega is equal to 2 pi upon t. So now these are the three important relations which we have got, and now here I will be now drawing a phasor diagram for this pure resistive circuit. Now this is a phasor diagram for this pure resistive circuit, and in a pure resistive circuit, the current and voltage are in phase. Current and voltage are in phase. Or in other words, we can say that the maximum and the minimum value of current and the voltage occur at the same time. So this is the phasor diagram for a pure resistive circuit. In a pure resistive circuit, the current and the voltage are in phase, or we can say that the maximum and the minimum value of this current and the voltage, they occur at the same time. Now, in order to express the AC power in the same form, means in the same form of DC power, we use a term by the name of this root mean square current and root mean square voltage. So I am just writing it here, that is, in order to express AC power, we use root mean square, we use RMS, we use RMS value of current and voltage. In order to express the AC power in the same form, of this DC power, we use the RMS value of current and voltage. And what is the RMS value of current and voltage? The RMS value of the current or the RMS value of the voltage, it is the effective RMS value of the current is the effect. You can say it is the effective current in an electrical circuit, and the RMS value of the current or of this voltage is the effective value of the voltage. And this RMS value of voltage and the current are denoted by, that is RMS root mean square voltage is denoted by V RMS, and or it is also denoted by V. Similarly, the root mean square current is denoted by IRMS, or simply it is denoted by I. Now, what is the root mean square voltage? This is the effective voltage of an electrical circuit, and the root mean square current, this is the effective current of an electrical circuit. So now yes, IRMS is, which is also known as I, is equal to under root of IM square divided by 2, or it is simply written as IM divided by under root 2. Similarly, VRMS, which is also known as V, is equal to VM upon root 2. Or in other words, we can say that it implies that VM is equal to root 2V and Im is equal to root 2I, where Vm is the amplitude of the oscillating potential difference and Im is the current amplitude. So these are the two important relations. So I will just write it here now. Vm is equal to root 2 V and Im is equal to root 2 I. In our houses or um, in houses and even in most of the offices and even the commercial shops, uh, the voltage, the line voltage is normally it is equal to 220 to 230 volts. Now this is basically the value of VRMS. VRMS, that is the root mean square voltage, or you can say this is the effective voltage which is flowing in the line. So in most of our this electrical appliances, you will see that they mention the voltage range. That is, if you are buying some, let us say, a bulb, you will find the voltage range which is written on the cover as, let's say, 220 volt, 222, let's say 240 volt. So basically it is saying that this is basically the RMS value of the voltage which that bulb is designed for. That is, the RMS value of voltage for which that bulb is designed for is 220 to 240. That is, this is the VRMS value. And now if you want to find the amplitude of this potential, that is Vm is the amplitude of the oscillating potential difference. So this is equal to root 2, that is equal to, it will be root 1.414 into 220. Let us say the line voltage in our houses is 220 volt. So the amplitude of the oscillating potential difference will be equal to 1.414 into 220, which is equal to this is almost equal to 311 volts. So RMS voltage and the RMS current are basically the effective voltage and the current which is flowing in an electrical circuit, and this is basically used in this voltage, the voltage which is supplied in our houses or the offices, they are basically the RMS values, and whatever the specifications which are given for the voltage range on the whenever we buy any electrical appliances, that is basically the RMS value for which that electrical appliance is designed for. So this is all I just wanted to tell you about this pure this resistor circuit, which is connected to an this AC source, which is producing the sinusoidal potential difference. And we have so in the today's lecture we have learned these few formulas, that is V is equal to Vm sin omega t, I is equal to Im sin omega t, where Im is equal to Vm upon R, and one more thing, now IRMS is equal to I, and VRMS is also known as V. Now we also know that Im is equal to Vm upon R, and Im, the value of Im here, you can say that is this is equal to root 2 I, and Vm is equal to root 2 V divided by R. So we can also say that V is equal to I into R. Okay. So where V is the RMS voltage, I is the RMS current, and R is it's basically a constant which we call as the resistance of a resistor. So this is all I have for the today's session, and in the next session, that in the session number 3, I will be discussing about the heat dissipation in an electrical circuit. So till then, have a nice day. Bye.